This is a way I just started teaching about 2 years ago how to do it. And some students really like it. It's called a 5-point method. But let's do some exploring first. So we're going to look at graphing these. You guys can already graph a little bit of periodic functions, right? Like that was on the quiz. With your amplitude and your periods and all that good stuff. Do we know what a sine function is?
Yeah.
On the unit circle, it is our y. Do we know what a sine curve is? It's the graph of a sine function. So when I'm referring to the sine curve, I'm talking about the graph. And the sine is the y. All right. So the period of sine function is 2 pi. We know that. Because our unit circle is 2 pi. Oh, I should have left that up there. So let's make a table. What are all my y values? You guys should keep, I should print out a unit circle for you guys to keep handy. It'll make your life a lot easier. What is sine at 0 on my unit circle? 0. And then it's 1/2 root 3 over 2. Ooh, real quick. At pi over 2, what's my sine value up here? 1. And remember, it's going to go up and then it's going to come back down. It's a periodic function, right? So then it'd be root 3 over 2, 1/2, 0, right? Goes up, comes like the Ferris wheel. 0, 1, and it comes down. And then we're going to go down into negatives. So we're going to repeat the same pattern, just in negatives. Again, this is straight from the unit circle, right? All my y values. I could have just looked at it and went around in a circle. But looks like a periodic function. Here are some key points I want us to look at. I'm going to highlight them. These are the 5 points we're going to look at the most because they're easy to graph, and if we move them or change them, they're still easy to graph, right? This is my max, this is my min, and these 3 are my zeros. 0, max, 0, min, 0. Okay? It's going to make more sense when we actually go to graph. But those are my 5 key points. Where do they show up on the unit circle are those ones. Because those are the easy ones to remember, right? They're either 1 or -1 or 0, right? So where is this increasing going up? From 0 to 1, right? Do you guys see that? So now, where is my x? Remember, where is x? So from 0 to pi over 2, I'm going up, right? And then I go down. And then where's my next one? This one, going from 0 to -1, am I going up or down? Down. Then from -1 to 0, I'm going up. So this is called graph. Whoa, Mr. Twilliger. That's your y. You don't want your y, you want your where. So I would do 3 pi over 2 to 2 pi. Does that make sense? On the unit circle, am I going up when I go that way? Yeah, and then I went down, down, and then I went up. So it makes sense then increasing on those two, right? So remember, it's a period, like this is why I've never taught this way, doing the periodic first, but the unit circle does work like the Ferris wheel, right? It's your height. Okay. So then where am I decreasing? Do you mind if I just write C over here? Go down a little bit. Where am I decreasing then? Now think about this. From 1 to 0, I'm decreasing. From 0 to -1. So this whole thing, I'm going down, right? From here to here, I'm going down the whole time. So there's only one interval. From pi over 2 2, 3 pi over 2. Which also makes sense because if I'm not increasing, what am I doing? Decreasing, because it's constantly moving. And, oh. Again, so I can keep my chart up. This is D. What's my max? Pi over 2, 1, right? If I want a point, what point is my max? It's pi over 2, 1, right? And that's a point. You guys remember doing this stuff a long time ago? So what's my minimum? Yep. Okay. Anything too wild? Flamingo math is wild. Shout out. It's not my stuff, it's hers. All right. Okay. Keep scrolling, scrolling, scrolling. I talked about we're going to use those 5 key points I highlighted before to graph this piece. Let's see what they look like on the actual graph. Oh my gosh, too much writing. All right. So I have 5 key points for sine. Oh, I already did it. I looked at the table. What was this first point was? 0, 0, which is a intercept. My second key point is going to be, and we show pi over 2, 1, which is a max. Third point is going to be pi 0, which is a intercept. Four is going to be 3 pi over 2 negative 1, which is a min. And why did I switch? That's how I usually do. And number 5 is going to be 1, 2, 4, 5. 2 pi 0, which is an intercept. And that will give me one wave of a sine curve, right? And then I just repeat, but that intercept starts the next one. You know what I mean? I would go max, intercept, min, intercept. That pattern will always hold true. Intercept max, intercept min, intercept max, intercept min. Okay? Does that kind of make sense? We go from a 0 to a max, to a 0 to a min, to an intercept to a max, to an intercept to a min. You know what I'm saying? Anything too scary so far? Okay. Let's get wild then. All right. Ooh. Good. Given some sign of that, right? Do you guys remember graph transformations? If I'm multiplying out in front, what am I changing, my x or my y? Your y, right? So that A is going to make it go up and down more. The B, is that going to change your x or your y? Your x. And remember, it's inverse. So if B is like 5, it's going to scrunch it like a fifth. You know what I mean? It's going to compress it a fifth. If that number is like a half, it's going to extend it by 2 because it's always opposite by the x. So let's think about this. So we know that, I don't know why they didn't draw. I'm going to draw a picture to help us out. So this is a sine curve. I'm going to go up A, down negative A. Does that make, because it's 1, I'm going to multiply it by whatever A is. And then this period, that's usually 2 pi, correct? But now what this is going to be is 2 pi divided by B. We're going to do a bunch of these. It's going to make more sense. But what's my domain of a sine function? Does it go forever in both directions? Yeah, it does. All periodic functions have to have a domain of all real numbers, right? Or else they wouldn't be periodic. So it'd be negative infinity to infinity. What's my amplitude on this beast? It's whatever A is, right? Not just A. I'm going to do absolute value of A, right? Because if I put a negative in front, does that change my amplitude or is it going to flip it? It flips it, right? So amplitude is always positive because it's a length. Amplitude is always positive because it's a length. Okay? So what's my range going to be? I disagree with that. My range would be negative A to A. Whatever number's in front, right? Because it's going to go down to and up to it. Because remember, my amplitude goes in both directions. And then my period's going to be, so my amplitude, my range gets multiplied by A, but my period gets divided by B because remember, it's inverse. It's inverse once in there. So is that enough information? Well, key points then are going to be intercept max, intercept min, intercept to draw one cycle of it. This is working really far ahead. If I put a negative in front, what two things do I switch here? Your max and your min, right? And it'll graph it because it'll flip it automatically. What's up? We aren't dealing with that yet. We'll see that in a little bit. Right now, we're just to affect it. Like if we were adding something to it, it's going to affect it. And we'll show what that does. But you're still using these key points, and this will always give you the graph every time, no matter what. If you do this, find your 5 key points and how they move, it'll always give you the graph. Okay, let's try it. Oopsie. Let's give it a try. Let's see if we can graph. Some of y'all are going to like graphing because it's done the same way every time. All right. Are these my 5 key points? Yeah. They're the corners, like the side and tops and bottoms of my unit circle, right? So, what am I graphing? It's 2 times sine of x. Okay. So I'm going to plug in 0. What's 2 times sine of 0? Well, what sine is 0 according to the unit circle? 0, right? So that's still 0. So I have the point, 0, 0. Which is good. I'm supposed to start with a intercept. Do I have an intercept? All right, good. Next, I'm going to do 2 times sine of pi over 2. What's sine of pi over 2? It's 1, right? So 2 times 1 is 2. So I graph pi over 2, 2. Because what should happen to my amplitude? What should my amplitude be? It should be double. It's 2 double 1. Yeah. All right, so far so good. Next I'm going to do 2 sine of pi. Sine of pi is 0. Intercept, max, intercept. Next we have a, I hope it's a min. I got negative 2. And what happens, what's sine of 2 pi? Did it work? Now when I graph it, should I make them come to peaks? No, that'd be goofy. Try to make it curvy. Now remember, that's one sine wave, right? If you had to draw another one, what would you do? Just repeat the pattern, right? Could I do, now if I wanted to draw, if they make you draw on the negative side, would I start by going up or down on this side? You start by going down, right? Just keep that in mind. Because you're taking this and you're copy and pasting it there, right? All right. How you guys feel about graphing so far? How do you guys feel about trig in general so far? Is it as scary as you guys thought? It might be. All right, let's do another one. Oh, Jiminy Crickets. Where am I going to get these two values from? Unit circle, right? Where am I going to get this one from? Dividing them, right? Sine divided by cosine. What's cosecant? Cosecant is 1 over sine. So what am I going to do with my sine values? You flip them. It's the reciprocal. So also think about this way. It's 1 over sine or h over o. It's what Santa loves to say, ho, ho, ho. All right. But do you see what I'm saying? It's the reciprocal of sine. It's not on your calculator. Cosecant's not on your calculator. If you see it, you do 1 divided by sine. It's really frustrating because cosecant goes with sine and secant goes with cosine. I know that's counterintuitive. So that would be h. Ha! We're going to deal with that when we do identities. And then what do you think cotangent is? 1 over tan, which would be a over o, right? So if I know these, you flip them to find these.
What's your sign for that one?
Ayo! Ho ha! Ayo! Ayo! Like you said, joke. Like, ho ho ho! Ha ha ha! Ayo! I don't know. I got nothing. No, I don't. You don't need, because I just have these ones memorized, and then you flip them. Flip the. Do y'all agree that this is 0, 1, 0, -1, 0? How did I do that so quick? Unit circle, right? Isn't cosine and sine the exact same thing, just shifted over? Could I use my unit circle as well? At 0, what's my x coordinate? It's 1, 0, -1, 0, 1. It's the same exact thing, just shifted over pi over 2. They're the same exact function. In fact, you can actually convert all your cosines to sines or vice versa if you want to. Now for tan, I just divide them. I'm thinking about what's 0 divided by 1? So tan of 0 is 0. All right, what's 1 divided by 0? Undefined, but I care about the graph. On a graph, what's an undefined slope? A vertical asymptote. So that's going to be a vertical asymptote. What's 0 divided by -1? 0. -1 divided by 0 is a vertical asymptote. Remember, whenever the bottom equals 0 for a function, it's a vertical asymptote. Oh, these tans look fun. They're a goofy looking graph. Do you guys want to know what they look like? Have you guys ever seen tan lines?
Yeah.
Like a farmer goes swimming, you see a tan line. There's infinite asymptotes. That's what tan lines look like. All right, so cosecant. Ooh, what is 1 divided by 0? Vertical asymptote. What's 1 divided by 1? 1. What's 1 divided by 0? What's 1 divided by -1? And what's 1 divided by 0? Oh, chimney crickets. This chart is something nice to, when we get done with the next 4 sections, maybe draw a little star or something by this to remind you. All right, and then secant, wait a second, Mr. Twilliger, if these are the same just shifted over, what about this one? Same shift over, it's going to be 1 VA, -1 VA, 1. This looks like a lot, but remember, these are the same. These are the same. Just shift it. You know what I mean? Don't memorize stuff in this unit. Know where it comes from. It'll make your life a lot easier. What about cotan? What's 1 divided by 0? What's 1 divided? Uh-oh. So remember, you could also think, so this is 0 over 1. So that's 1 over 0. this was 1 over 0, so this is, you flip them, right? So this would be 0. These two are the exact same thing too, just shifted. This would be 0 VA, 0 VA. This, if you can graph these, you're going to be able to graph these really easily. Just trust me on that, okay? You look so unimpressed. Look like a turtle. All right. Like a Teenage Mutant Ninja. All right. That was a lot of writing for a young man. Even more for an old man. All right. Oh, no way. All right, let's try another one. So Mr. Terwilliger told me, could I have an idea of what's going on with this before I even graph it? What's my amplitude going to be? 3, right? It's going to go up 3. What's my period going to be? 2 pi divided by 2 is pi. So I should get a whole wave in by pi. It's going to go up to 3, down to 3. And the negative's going to flip it. Let's see if we're right. Now I'm going to show you how to do this using a rule. What am I doing to, I'm going to take my x, y. What's going to happen to all my y coordinates? What's that? I'm going to multiply them by -3, right? And what am I going to do to every x coordinate? I'm not going to times by 2, I'm going to divide by 2, because remember what happens in the x is opposite. This is a short, do you see what I did there? It's kind of a short, could I go through and plug in 0 and solve it? Yeah, I could. But this is a way, I know my normal point is 0, 0, right? So that's going to be 1/2 times 0, -3 times 0, right? So it is still 0, 0. And I know that's going to work because I always start with a intercept. So for my next one, I have pi over 2, 1. Now, could I plug pi over 2 into my function, solve it, and graph it? Yes, but I'm showing you a shortcut way to do these. So I'm going to do, my next point is going to be 1, or actually that won't give you a whole one anyway, so I'll only give you a half. I'm going to do 1/2 times pi over 2. You see what I'm doing? Because it's over 2. And then -3 times 1, right? So I'm taking my 5 points and I'm plugging them in. So that becomes pi over 4, -3. Pi over 4. Wait, it's supposed to be a max next, Mr. Terwilliger. What happened? Because that negative, right? The negative flipped it. So it's actually me intercept min, intercept max. You don't have to worry. If you plug them in, you're going to get the right answer, right? It's just a way to check yourself. So I'm going to do 1/2 times pi, 0 times -3, right? So that's pi over 2, 0. Y'all agree on that? Which is good because I know that should be a 0. Could I cheat? Like if I'm doing this for homework, at this point, since I see that, are you going to know that that's going to be a 0? Yeah, can I do? Actually, at this point, could you also say that this is going to be 3 without plugging it in? Because what's your amplitude? 3. Does that make sense? Like, if you're just graphing, would I go through and do this every time? Not necessarily. If I know the amplitude, I know the period, like, could I have graphed this without even doing any points? Yeah, my period is pi. I know I'm going to start -3 to 3. You know what? Does that make sense? Like, you don't have to, but you can always do it this way. Okay? Both ways. There's more than one way to skin a cat, as Elf used to say. That's a really old, obscure reference. That's for all my homies on the channel who watch our old. Did I get the same thing? Yeah. And then lastly, 1/2 times 2 pi. 0. I'm not going to, it's 0, right? If you do it this way, though, it's no, you don't have to think much, right? You just go, I'm going to take my y times it by -3 and divide my x by 2. Do you all know why it is that way? Because technically, isn't this the function? So it's actually opposite on both, right? Because that's y divided by -3, so I times by -3. That's x times 2, so I divide by 2. It's just when I move it over, it's not. I don't know. Oops. Oops. All right. Do I have time? I do have time. I do have time. I do have time. Did I even give you any problems? Oh, I gave you guys some straightforward problems. All right. Let's do one more. We're going to do it the same. Oops. Describe the transformation. We didn't do that. What do we do? Flipped. Flipped. Which way? Horizontally or vertically? Vertically. We vertical stretch of what? Stretch of 3, right? And then horizontal. Do we stretch or compress it? Compressed it because it's always opposite. This is a nice little review of stuff, right? Of 1/2. Could I say vertical dilation of 3 and horizontal dilation of 1/2? If you're a nerd, yeah. And you guys are all nerds. I'm sorry, that was mean. Yes. Was it in the land of the blind, the man with one eye is king? Or there's a good movie with Norm Macdonald from back in the day, and Chris Farley, actually, that was in the land of the skunks, the man with no nose is king. All right, let's do it. On this one, I'm going to take my xy as anything happening to my x. Nope. They're going to be just fine. What's that? So I'm going to multiply my y by 2 and then do what with that plus 2? It moves it up 2. So I'm going to take my y and I'm going to times it by 2 and add 2. You guys could have been doing this with any transformation, right? And just treating it that way. But there's not 5 key points in other transformations. There's 1 or 2. So what's 0, 0 going to go to? It's going to go to, my 0 is going to stay. What's 2 times 0 plus 2? 0, 2. Mr. Wilger, that's not an intercept. Because what do? We shifted it up. Do you know how I had you guys sketch in midlines? What's my midline going to be on this? 2, because we shifted up 2. So if you want to think about your intercept's going to cross your new midline. Does that make sense? And now for my amplitude is 2. I'm going 2 up and down from that new midline I drew, right? So what's going to happen to pi over 2? 1. The pi over 2 stays. What's 2 times 1 plus 2? 4. So I have pi over 2, 4. Oopsie. Yeah, that's right. So right away, once I get this pattern, could I actually go and graph it without even writing these points? Because what do I have next? A 0, a min, a 0. Does that make sense? Because this distance is going to be 2. So I would be 0, min, 0. Does that make sense? Once you see a pattern, could I have graphed that without doing any of the points if you get good at this? Yeah. But I'll show you why. What's pi 0 going to go to? Pi 2, right? 2 times 0 plus 2. This one's going to go to 3 pi over 2. What's negative 2 times negative 1 plus 2? 0. And then I'd have 2 pi because my x is unchanged. What's 0 times 2 plus 2? 2. I was right for once. So now if you are a type of person who can look at this and start graphing it and realizing what's happening to it, you can. You do not have to do this method. If you're a type of person who wants to make sure you do it right, this way will work every single time, okay? And no matter what, yes, this way will 100% work every single time, okay? Again, 2 years ago was the first time I ever taught it this way, and a lot of my students loved this way because they just knew they didn't have to think about it, you know what I mean? It's just what happens to x, what happens to y, you know what I mean? If you more like want to know, my amplitude's going to be 2, and I'm shifting it up 2, so I draw midline and my new amplitude, go for it. That's the way, this way, that way's quicker. This way will work every single time with every function we do. You know what I mean? Like, we're going to graph 6 different functions. They all work this exact same way. That seems pretty fair, right? Oh, geez.